think it's time. We are going to start. I hope you can hear me in the back. It's okay? Yeah. No have to wear that. I'm not very used to using a mic. So, my name is Marian. We work on a small company in Romania called Acorn IT. We are doing mainly consulting and bespoke software. We have a couple of products ourselves. The technology that we use are mainly Progress, or we work around that Progress ecosystem. It doesn't have to be necessarily only Progress. We use Java and Node.js as well as other technologies that the customers are mainly coming from the Progress user group, so that's why we are here. We usually go to those kind of events, so we try to participate in the Progress community. The session today is going to be about testing, so if you have any doubt or the message was not very clear, it's going to be about testing. It's a warning, it might be boring at some time, so just a fair warning. So let's start. That's the definition of testing. It's actually the process of trying to see if a piece of work behaves as it was designed to work, or as it should be. That's the definition. How that translates to the software development. In software development, we have that concept of the software testing, and which is the process of evaluating and verifying the result of the unit test that we are trying to see how it behaves. If it follows the specification, there are many things that we have to be aware when we try to do software testing. It's not just the functional implication of that unit of code that we are going to test. There are other non-functional stuff that we might look at, like performance, how is going to be, how is the usability for the user perspective, and that kind of thing that also fall in the part of the testing. Over the time, there were many types of software testing. So the purpose of that software testing was to enhance the quality of the software that we provide to the customers. That's the main scope of the testing. Wonder how many of you are using testing or have anything related to testing in your software development activities? Okay. So, yeah, that's good. There are many of you doing that. How much and what is the level of testing that we are doing in our application? It can range from no testing at all, so we just implement new feature and we ship it to the customer so they test it in production, to have a full testing procedure implemented into a software life cycle of our application. But we have to start from somewhere. If we don't do anything, I think now is the time. If you don't do any testing on your application, I think it's a good time to consider start doing something, because it's going to pay off at some point. It takes a lot of time and, of course, a lot of money if we try to invest in testing, but eventually it's going to pay off with a better quality of product that we ship, more, let's say, happier customers, because they don't have to deal with the bugs that we ship when we also add a new feature. And it's something that you might want to think about when so to put it somewhere in your software development life cycle. There are a couple of testing flavors in software testing. The most common one, and this is what we are going to talk about mainly in this session, is the unit testing. So as a developer, we write unit of code. You can see a unit of code as the smaller piece of the software that does one thing. As a developer, maybe we think that the unit code should be as smaller as possible and do a single one thing. So that's a concept that we run by when we do software development. This is also helping us when we write unit testing, because if the unit of code is very small, it's easier to test it. If the unit of code is very large and does a lot of any other things and interact with another system, then it's going to be very difficult for you to write unit tests to see that unit of code is actually behaving as it should be. So the focus is the smallest testable component of the application. Whether if you are using procedural code or object-oriented code, it's always the smaller piece of the code that you can test. So it can be either an internal procedure, internal function, or a method if you are using object-oriented code. This is the stuff that we are working on when we talk about unit testing. Another type of testing is the integration testing. This is a little bit more. This is checking actually different part of the software and how they interact together, and ensure that the fact that they collaborate and integrate correctly. So it's a little bit more. It's the next level than unit testing. It actually testing how the component interact one to another. And of course, acceptance testing. This is part of the QA activities most of the time. Whenever you try to push a new release, the quality assurance goes through those acceptance testing and ensure that the whole system works and the functionality of the system it was implemented as designed. So it goes also as to test the whole system. In that particular case, it's some kind of manual testing, and there are power users that are involved in that acceptance testing. It's not something that we run in an automatic way, as we do with unit testing. Some other type of testing that we can think about and we should probably add to our testing strategies is performance testing, where we want to see how performant is our system. Maybe functionally it's okay, but if your function or the unit code that you wrote is taking a lot of time to respond, then you should do something about that as well. And related to that is the stress testing that also tries to find out not only how good the system is performing, but what is the breaking point, when the system is going to fail. What is the load that is going to make your system fail? And of course, you saw that a number of times during the session before. Security, it's a big concern nowadays, and security testing can also be something that you might think about. If you have endpoint, anything that is publicly available to other systems, then you should test those systems for security issues or any other vulnerability. If you use third-party libraries or anything like that, you should always constantly check if there are any vulnerability that were reported for the library, so you can upgrade the library or any other external system that you are using. Always make sure that they don't have any vulnerabilities that were discovered and might be exploited, so you should always keep up to date with that security threats. This is how the software development lifecycle look like in most of our software development companies. It doesn't always have to be that complex, and for people using Agile, maybe it doesn't have all that many blocks. I don't know if your software development life cycle looks like that or close to that. Are you using Agile, or what kind of methodology do you use? Everybody's using Agile nowadays, but it's like AI. Maybe you just say, I'm using Agile, but whatever. Anyway, it starts from planning, then goes through a phase of analyzing the requirement, and the business users are involved in that part of the phase. Then, once the requirements were refined, then you start by designing. Designing also take the big architecture part, and going down through the modeling of, I don't know, can go down to the class diagram and integration and that kind of thing, or documents that you might do during the design phase. Then you actually start to implement that, and the developer start working on the specification that they received. And after that implementation phase, that testing phase should be somewhere before the release phase, because it doesn't make any sense to test the application once you already ship that to the customer. It's a little bit too late. Now, how do you integrate testing in your development lifecycle? It can range for, as I said, you don't have any testing at all. You just do a testing just before the release, or you have that integrated into the development activity. So whenever a developer is checking in code, there are some unit tests that has to be written, and there has to be, you can set a threshold of code completion that has to be, code coverage that has to be met, and it can be a situation where you cannot even check in your code if the unit tests are failing. That's probably the best place to be. But if not, at least before the release, try to run any tests that you might have and see that there are any bugs that, at least that you know of, when you ship at the customer and you release. It's always going to be new bugs that we probably don't know about it, because there is no such a thing as 100% code coverage. Something that we didn't think about to test, some corner cases that we never thought that is going to happen, it can happen in production. But the point of testing is just try to reduce that, let's say, bugs or things that we didn't thought about. As I said, most of the people are using Agile, and with Agile, it's not really a consequence of Agile, but it's probably something that comes from using Agile methodology. The DevOps emerged, so now we have teams that actually bridge the gap between the developer and the people that's doing the operational side of things. The DBA, the people that's doing the configuration and setup of the systems. So yeah, I think it's a good thing, because it brings those people together, and they can communicate and learn more about how, as a developer, we learn more about how our code is behaving in a production environment, and the operational side of things can also find out more about what we are trying to do with a specific piece of code. Yeah, there is also a new concept like ARCOPS, where the software architecture artifact comes into the play, and everybody knows more about the big picture, what are the system involved, what are the components of the system, how they communicate one to each other. So then the developer can see more than just the code that it's trying to implement in let's say ABL, if they are ABL developer. And the last part of that was people started to, as we know, probably the facilitator for the continuous integration and the delivery is the containerization, that it's available and it's very easy nowadays to set up systems and use those for testing. You can run your unit testing overnight, or you can run them whenever you try to merge a development branch into the master branch. You can run regression testing once in a while, or maybe every night. So you always get the feedback and know how you are going. Are you improving quality? Are you making it any worse? Because sometimes when we add functionality, it always, as the complexity increase, the chance that we add new bugs also increase. So it's very important if you can afford to have that continuous integration and continuous delivery process set up in your organization. That is going to help you a lot. But it's, yeah, for most of us, it's probably just a desire. So we want to get at that point where we have unit testing and we have everything set up. So we run that and we constantly see the dashboard, how we are going, are we getting better, or rather making the software less stable. Some of the reasons why we started to do testing in general, not unit testing, can be also manual testing or any kind of testing. Yes, it does take time, it takes a lot of time, and as a consequence, it costs us money. If our developer need to also write unit tests, then they are less productive because they don't write as much productive code or let's say application code, because they have to spend some time on writing unit testing. But it also can help with a number of things. So you can actually see the problem before it goes to the market, before you release that to the customers. It avoids defect, and as a consequence, it also even it might look contra intuitive. It can even prevent late delivery, because it might make a lot of more time to write the unit testing, but you discover bugs that earlier in the process, so you can actually meet your deadline if you have unit test, then rather than not having any unit test at all. And of course, it protects your brand reputation, because it never looks good if you send new releases to the customer that it comes with a new set of bugs that it might make the rendered application unused. There are some figures. Only in 1 year, in 2050, the cost of the failures, of software failures in the US economy was estimated to be $1.1 trillion. So it's actually quite an important cost. So it makes you wonder if you can afford to say, well, we don't need to test our software, we just ship it to the customer. And because sometimes as a developer, we don't think about the consequences of our the thing that we write. It's just a software. It cannot harm anyone, but it turns out that the result can be quite important and affect so many people sometimes. Not only in terms of money, but also the people that are affected by that. Some of the cases here, some of them are just old. The last one probably is something that is still in your memory. Is CrowdStrike, where a case where software, I think this summer, in June or July, something. Ironically, antivirus software company just pushed an update, and that made stop all the Windows system in a cloud environment. So there were a lot of 8.5 million devices affected. So I don't think if that actually helped to the company reputation for CrowdStrike. There are a couple of testing approaches that we can adopt. Manual testing or ad hoc testing. This is something that, as a developer, we always do. When we try to see if a piece of code works, we just try to write small piece of ad hoc code to see how it behaves for a specific case that we want to think about it and try to see if it works. These are less structured code, test code that sometimes doesn't even make it to the unit testing code base. So it's something that a developer just try to craft it and see if the function that he wrote behaves as is expected to be. For a larger system, however, we use a tool to automate that unit testing, because if we start writing unit tests, the number of those unit tests are going to grow over time, and there is no point in writing a lot of unit tests if nobody is running them and checking what are the results of the validation that is done by the unit testing. So that's why there's always a requirement to automate those tasks, because we want to be able to see what are the results of those unit tests and act accordingly. If maybe we change something in one component that is going to affect another component, so if we are able to run the unit testing, we see that. If we just do ad hoc testing on the component that we change, we might not see the implication, and we don't see that the thing that we change actually affect another part of the application. The part of continuous testing, that's a concept. You always have to try to test stuff. It can sometimes start from the defect or the bug tracking. Those are the best candidate for writing a unit test. If your customer is filling in a bug, then you know that you have to write a unit test for that, so you are sure that the next time you touch that code base is not going to, you are not going to reintroduce the same bug, let's say. So just write a test cases for, or a series of test cases for each bug or defect tracking that you get in your system from your customers. It also involves configuration management. This is when you start building a testing component as a whole, because when you try to test different components that interact with each other, then you have to start doing some mock-up services or data stubs, and those type of testing component, it has to be somewhere managed into your testing environment, so they have to be configured somewhere. You have to know that for a specific system, we have a mock-up server that it's running on that specific system, so it's accessible through that URL, and those are the configuration, the credential that you have to use, for instance, and that kind of thing. Those are always part of the configuration management, so you have to know what is going to be used in the testing. Of course, we need test environment, and now, as I said, because of the Docker and that containerization, you can actually make it's much more easier now to set up those test environment and make them available for the continuous integration or continuous deployment processes. Yeah, that's service virtualization, and of course, after that, we need to somehow find a way to get the metrics and the reporting from the stuff that the unit tests that we were running, and see how we stand. Should be somewhere on the green side of things, not approaching to the, not going to the red side. Okay, so unit testing. This is, as we said, it's the smallest functional unit of code that we need to test. If you are using object-oriented, that's probably most of the time a method. If you are using procedural code, then it's either a procedure as an external procedure as a whole, or internal procedure or internal function if you have something like a procedure library or that kind of thing. It helps you ensure the code quality. It should be part of the software development life cycle. And as I said, writing software as small as possible, the unit code as small as possible. You saw, I don't know if you, I think Roland Piper had a session about code quality. Having your unit of code with less than 60 line of code was considered already a high risk. While in progress, we have sometimes unit of code that go through, I don't know, hundreds of line of code and maybe 1,000 line of code. It's not unnatural to see something like that in progress. So the larger the unit code that you have to test, the bigger the complexity of the test cases that you have to write. Yeah. Some of the requirements for writing a unit test. The unit test really has to be run in isolation. It doesn't have to interact with any other component of your application or with an external system, because then you are ending up testing something else, not just the unit of code that you want to test. We are testing external system, maybe if they are not available, maybe they don't respond as it should be. So it has to be run in isolation. Otherwise, you are not testing exactly just the unit of code. Ideally, the code unit must be independent. What does that mean is that whenever number of times you try to run that unit of code, and at any point in time, if you just passing the same parameters, it should come back with the same result. Because if the results are different in time, maybe, then you cannot really test that. Because what we do in unit testing is, okay, I give you a set of input parameters and I'm expecting the results to be that. If that's change in time, then it doesn't make any sense to write a unit test for that specific unit of code. If you need to access external data or external system, it's better to mock up or use data stubs. Because, as I said, external system is something that we cannot control. They might be not available, they might have bug on their own and they change the functionality and they respond different ways as we expected them to respond. So we are not really testing our unit function, we are testing the external system, and that introduces a factor that can make our unit test fail. there can be multiple unit tests for each unit of code. As I said, if the unit of code is quite complex, then you have a lot of test cases that you need to write for that. Let's say that it's a little bit tied to the number of parameters that you passed in and the cyclomatic complexity of the unit of code. You somehow have to find out all the possibilities that can be used as an input, and inside of that unit of code you have to figure out what are the logical branches, what are the cyclomatic complexity from where the code can go. So you should be able to see if you cover all the cases or at least most part of it. There are some couple of strategies that you can use. As I said, if you put it in your development workflow, then write the unit test as you code. There is also a concept of test-driven development, where you should define your functional unit and define the functionality, functional requirement, and then you immediately start writing a unit test for that without having any implementation. So all your tests are going to fail, of course, because they are meant to fail. There is no implementation. And while you write the implementation, the purpose of that is that at the end, all the tests that you wrote up front is going to pass. So then you have valid implementation, let's say. I haven't seen any situation where this test-driven development was used. Maybe you can change my mind. Is anyone here doing that?
Here's your production grade.
Okay. So what we try to accomplish during the unit testing is to check the logic. So there's the happy path programming that we have to check if we give valid data, it responds as it was specified. This is the logic check. The boundary check is we try to use the smaller and the maximum, the higher and the lower values for each of those accepted input values. It should work as well. What if we give him invalid input? What is the error handling that it happened? Is there any error handling? How the unit code is going to respond if we give him invalid input? And of course, sometimes if the unit of code is changing persisting object, we have to check the state of those objects to see if there was as it's supposed to be. For instance, if it's changing some data in the database, we have to go and check the database that the unit of code did what it was supposed to do. Some of the best practices that you can use when starting to write unit testing is always use a framework. Don't try to roll your own. There were two or three, I think. Although I think ABLUnit and ProUnit was never used that much. What are you using? ABLUnit. Yeah, because everybody was switching from ABLUnit to ABLUnit at some point. So ABLUnit is provided by Progress. Try to pick one that it can be automated. ABLUnit provide end script that you can use, both an end script from Progress, that it comes with your installation, or PCT. If you already use PCT also have an ABLUnit task that you can also use. As a rule of thumb, that's assert one. Remember the one word, one wait for. It's the same for unit testing. Don't try to assert multiple things. Test all the functionality of the unit of code in the single unit test, because the first one that is going to fail, it stops the unit test, the specific test method. So it's always a good idea to assert just one thing in one test method. Keep it simple. Don't try to get smart. Don't try to build a new framework that is going to help you with the testing. Don't make new classes that is going to do all the asserts that you are looking for. Remember, it has to be only one assert. It doesn't matter if you have code duplication in unit testing. You're supposed to have code duplication in unit testing. Don't try to make that as a framework, because then it's going to be harder for you to figure out where that part was failing and why. So just try to keep that simple. As I said before, just try to put that in your development process. Whenever you write a new piece of code, write a unit test in the same time. It's going to save you a lot of time, because nobody wants to go back and start writing unit tests for something that was developed by somebody else, and they spend a lot of time trying to figure out what is the unit of code trying to do, and it's like a black box testing in that case most of the time. We sometimes have to do black box testing because we don't know. We have a third-party component that we are using, and even for that we can write unit testing. If they provide us a new version, then if we have unit testing, we know that the behavior hasn't changed. At least the behavior that we expected as it was before. Test cases. Write a test case for each unit of code. Don't try to test multiple units of code in a single test case, or if the unit of code is very complex, you can probably split that test in multiple test cases, but just try to use one test case for each unit of code. That's the general idea. Separate test method for each test scenario. Yeah, just don't try to put all the invalid values test in a single test method. Write a unit test method for each those invalid combination. Invalid input. As I said before, it doesn't make any sense to test all the valid values for a unit of code. If it's going supposed to work with anything between 1 and 1,000, just don't try to test 1 to 100 each values. It's okay if you already tested the boundaries. It's okay. So don't try to go to an extreme. And of course, as it is anything in development that applies to unit testing, you have to use some kind of naming convention. So split your test cases in packages, let's say in folders, for each component that you are going to test. Probably should match the same structure that your unit of code already has. Those are the annotation of the ABLUnit. The test annotation, it's used for any test method. Test method can be, as we are going to see, that it's either procedural or object-oriented, but let's call that a test method. Here I use, this is a little bit confusing for me, because setup it's running before each test, while before is running before all the tests is in the class. I rather be using the technology that Java is using, before each.
Progress just updated that.
I know. Yeah,
and it's
I
before
know.
all, before each.
I know.
I'm getting confused as well every single time.
Yeah. They actually managed to do that, I think, in 12.8. Yeah. But before that it was like that. So before it's something that it's running when the test class is instantiated, and it's only running once for the whole test method, while setup it's running before every test method that you have in a unit test. Tear down, it's running after each test, so it's going to run one time for each test method, and while after it's running only at the end of the test class. As you suspect, probably before and after can be used to set up the context that is going to be used by the whole test class. While the setup and tear down, it sometimes can reset that global context. For instance, can use that for resetting the context, or it's something that is doing cleanup. The after part is trying to reset the state to what it was before. Sometimes it makes sense to use the before method if you have a very complex stage setup that has to be done, like, I don't know, creating a data set, loading data into that data set, and a lot of stuff that you have to do it up front. That takes time. It doesn't make sense maybe to do that over and over again. But problem is that if you do that, that is going to be global scope, and your test method it shouldn't change that. Otherwise, you have to reset it back to the same scope, because changing the global state is going to make that test method fail at some point. If you add a new method that is changing the global scope, the next method running after that might expect a different scope as it was before. So never try to base your test method, write your test method that taking into consideration the order of execution of those test methods. So try to always start from the same context, from the same state. Of course, there is another annotation that I never put it here. It's ignore annotation. Okay, let's just ignore that. I don't see any reason for writing a test case or a test class just to be able to ignore it in the end. If you put an effort in that and then use it. If it's not used anymore, just remove it. It's just like a dead code. Don't bother to use that annotation. I think it shouldn't be there in the first place. There are a couple of case flavors for the test case flavors. Because the progress is procedural and object-oriented, we also have that in test cases. You can write either a test case as a procedure or as a class. For a procedure, all the test method has to be internal procedures, while for a class, the test member and all the setup and tear down method has to be, of course, method. Yeah. The test class has to have a public default constructor, otherwise the ABLUnit test framework is not going to be able to instantiate the class. So if you write a private constructor to it, it's going to fail the test cases. Must be public, doesn't have to have any parameters, otherwise, of course, it's not going to be able to instantiate it. All the test method should be public as well, because otherwise, again, it's not going to be able to dynamically run those methods. It's using reflection probably, so it has to be public. Doesn't have to have any parameters. Again, it's always trying to just call them test method with no input parameter, so if that the method require a parameter, is going to fail. Inheritance doesn't really work, so don't even bother to try to say, okay, I'm going to try to write a test case for a base class, and then I'm going to extend that for an actual implementation of that base class. It doesn't work like that. It doesn't execute the annotated test method from the base class that you are trying to extend. It just reads the test method in the class itself. So inheritance doesn't work for the test classes. For procedure, it's the same thing. Internal procedure doesn't have to take any parameter. Don't flag those as a private because it's not going to be able to run them. And if you try to use function instead of procedure, even if you annotate them, just ignore. They are not able to execute functions. It comes with a part where we actually do some testing. The most part of the testing of unit testing is we run some kind of functionality and then we assert the result. We test that the results are as expected. For that, we can use OpenEdge core assert. It's a class that has a lot of static methods there that you can use. Plenty of assertion. Sometimes there is an overlap, or they just change their mind at some point. There is a non-zero or not zero. It basically do the same thing. When you are using equals assertion, try to match the parameters order. The first one is expected, the second one is actual. Otherwise, it's going to give you a little bit of mixed up error messages. So the documentation of progress looks like that. That equals method takes an A as a first parameter and B as the second parameter. It's actually expected and actual. It's just saving some keystrokes there. For other method, assert method, it's always sometimes a parameter name that you can find at the end. It's actually make it more clear what it's not null, what it's supposed to be null, and it is not null. So if you use that last parameter, it's a character that says that I don't know, the age shouldn't be higher than, I don't know, 100. Let's say maybe we should change that at some point. But like you see here, for is false, the last parameter is the argument name, so what is false, what is expected to be false. It makes it more clear when you see the result of the ABLUnit test. If you don't see any assertion that fits your requirement, you can always do your assertion and checks and whatever, and then if it doesn't meet the expected result, just throw an assertion failed error yourself. There is also a method in assert that you can use. Rise error is going to throw an assertion failed error. Once we started to create a number of test cases, we can put them together in a test suite. The purpose of that being that we want to test the whole component and we want to run all the tests in one go and see that there are no any other errors. The component behaves as expected. So we can group all the related test cases in a single test suite. Don't try to put together test cases that are meant for another component in the same test suite, because it's going to fail the whole test suite if only one component is failing. So try to group them if there is a relation between them. Otherwise, just don't put them together for the purpose of just running them in a single go. Although that might be an option as well. Those test suites can be used as when you try to run regression testing. If you know that you touch something for a specific component and you have a test suite for that specific component, run that test suite to see if there are no side effects and you didn't introduce any new, I don't know, unexpected functionality that breaks existing functionality. So at least we are not getting better than we were before. When you write those test cases, as I said before, you shouldn't consider the global state and write them in the order that, I don't know, maybe the first test method is updating the global state and the second method is expecting that the state it was updated to that point, because somebody can comment at some point and add a new method that is also changing that global scope. So the scope is the state of that global variable is going to be different than when the test cases was written. So that is going to make the test case to fail. Those are the annotations that you can use for a test suite. So of course, just very simple. Test suite is really just a placeholder. It can be a class or a procedure. It doesn't really make any sense. I think it can be even just a test file with annotation in it, because what Progress does, it doesn't even try to instantiate that class or run the procedure or anything. It's just reading those test suite annotation. This is the only thing that it does. Even if you make a class, a test suite class that has a private constructor, Progress doesn't care about that. It's going to be able to read the annotation and run the test suite. So it doesn't try to instantiate the class. Whatever you are putting in the constructor for a test suite class or in the main block of the test suite procedure is not going to be executed. So don't even bother to put anything there. There are two things that you can put there. If you are writing test procedure, test cases procedure, then you have to specify the procedure, and then it's the relative path, let's say, to the procedure, relative to the propath. So you have to specify this as a full path or relative path to the propath, including the .p. So it's the test case procedure that is going to be executed, and a comma separated by comma. For the test classes is not the name of the file that implement the class. It's actually the .com. It's the full package, full name of the class. So it's package followed by the name of the class using the dot notation, as you specify that in object-oriented. What we find out at some point is that you can mix them together. So you can have also classes and procedure in the same annotation. You can have multiple annotation, and there is a limit of character for those annotation parameters. We've hit that a number of times. So the first thing that we did was to try to split those in different test suites. So we had test suite 1, test suite 2, test suite 3, just because of that limitation. The limit, I don't think is documented. It's about 10 kilobytes or something. So we try to keep that values lower than 10 kilobytes. But the good thing is that the good news is that you can use multiple annotations, so you can just add multiple annotation to that test suite file. So really no need to split them in separate files just because of that. It's the same. I already mentioned that you can write that as a class or as a procedure. Really doesn't make any sense to write anything in it. It's just the Progress read that as a text file, so it just goes for the annotation. So you can pick whatever floats your boat here. It's not really important. What we found out what are the error handling approach that you have to use in when you write unit testing. Always use the block level, routine level. You probably use that already whenever you start a new procedure or class. Put that on the first line of your code. Otherwise, the errors might be hidden, or it's just going to pop up as a debug alert box when you run the unit test. So put that in front of your unit testing. Inside of test method, just don't bother to use catch or no error statement. Just let the error pop up. It's not going to be an assert error, but at least if you run everything with no error and then try to do an assert, it's going to give you that, okay, this data assertion failed, but what was the cause for that? If you are running your statement without no error, then you are going to see that what was failing actually there. In before all method, try to catch the error, because if you don't catch the error in the before all, let's say, it's going to make the test case show like never run. So the run number says like the number of the unit test method that you have. Execution is 0, errors are 0, and it doesn't make any sense. It has an error. It doesn't run any test method, but it reports 0 error, 0 failure. So it looks like your test somehow passed. Try to catch the errors in the before all. If you have any errors in the setup method, all your test methods are going to fail and are going to be marked as error. If you have error in tear down, it's the same as for setup. It's actually progress run, the setup, the test method, and the tear down in the same as the same unit. So if any of those fails, the whole test method is going to be marked as failure. Errors in after, so at the end of the test class, doesn't affect the result. If it's any error there, it doesn't matter. So global test, I said that it's always better not to use global test. Even for development, it's always better to have local scoped variable and use that inside the unit code instead of moving that at the class level or procedure level and use that as a global scope. Very complex to set up, so it's always very difficult to bring back to the same scope that we had when we started the testing. As a rule of thumb, what we did is if we really have to use global scope, and we sometimes have to do it, temp table data set, you cannot define that inside of a method, so you have to be a class level global scope, let's say data structure. You should only set up that in before and then consider them as a read-only. You don't change them inside of your test method. If the test method updates the global state, ensure somehow that it restored back to the original state. And also, sometimes you have to take into consideration session global scope, like session system variable, session global system handle that might affect your testing, like, I don't know, things like date formatting, numeric format. Those kind of thing might make your unit test fail if it doesn't match the same values as when you wrote the test cases. For persistence, and I mean the database here, it's really, you should try to treat the persistent layer as an external system. So the persistent layer cannot be trusted because it can change. Somebody else can run another unit test and it can change your database. You have to find a way to isolate that. One way of doing that is probably using local databases that you can create and trash away, or use Docker instances that you can start up and you are sure that you are the only one that are using them, or that kind of thing. You have to find a way to mock up or provide data stubs to your unit testing. There are two options here. You can either try to clean up or reset whatever you did at the end of the test using maybe a finally block. If you probably can use transaction during that test method, and at the end try to roll back that. That might be an option. Or you can go with a zero trust approach. So I don't bother cleaning up after me, but whenever I start a new test method, I ensure that we start from the same ground state. As I mentioned, that scope transaction and rollback is one option that you can probably use if your test method are updating the persistence layer. Because whatever transaction that we did and we try to change the persistence, if we try to roll back at the end, we get back to the same situation as before. So we don't actually persist that in a database. Another option would be to reload or somehow restore your database to always start from the same situation. Sometimes we have to use external systems. You make a REST API call to some other system, or I don't know, SOAP call, a web service call, or you just access another system database directly. You have to do some kind of mock-up for that, because we have to isolate our component that we are trying to use, and all other components that are required has to be mocked up. It doesn't have to be a real system, because we are proof those can affect our testing. The basic concept when doing mocking is that we set up the expectation inside the mock. We run actually the functionality that we want to test, and then in the end we use the mock to verify the expectation. The state on the mock, it's actually what it's supposed to be. This is the outcome, let's say, for our functionality, but also the behavior. How many methods there were, what were the interaction between our component that we are testing and the mock server. It's sometimes very important. For instance, if you have a REST mock-up servers, that you say, okay, when I'm making this GET request to that using those path parameters, I'm expecting from you this specific JSON output. You can mock that, but you should be able to tell, okay, when I run my functionality, I can see that it was a method that called that mock server, and that mock server responded in that specific way. So I'm going to be able to check that actually my unit of code behaving as it should be. Unfortunately, there are not, at least not yet, no mocking framework for Progress or OpenEdge. You cannot, for instance, if you want to use a class or that you don't want to test it, you need that test, that class, that component, if you test your functionality, but you don't want to depend on the implementation of that class, because that class might be the problem, not your unit code, not the unit of code that you are testing, but the actual class that you are using. So then, in other languages, it's very common to use mocking framework that actually build mock classes for the component that you need during testing. That might probably be an idea for, I don't know, a project, or we can put that for Progress to start thinking about. Also, automation, it's something, as I said, you should think about it. Maybe it doesn't have to be implemented when you start testing, but at some point you have to find a place where you be able to run those tests in an automated way, because nobody wants to just run the testing and see the result. Those has to be done automatically. The metric has to be gathered and made available to the developers or the operation to the DevOps, so they should be able to see how they stand. They don't have to run those tests manually. It's important sometimes for if you use PCT or the ABLUnit end task from progress, it's important to figure out what is the value that you want to use for halt on failure or halt on error. For instance, if you are running, if you have that integrated in your development process, then if you want to prevent the user to commit or merge his development branch to the master branch, you should specify here fail on error and fail on halt on failure, halt on error to be true, because you want to stop that process at that point. You don't want to let the developer go on and be able to merge the development branch to the master one. If you run that as a regression testing, then maybe it's better to let those two be false. So I run all the tests, it doesn't matter, it's not going to stop at the first one that was failing. But sometimes it makes sense to go on and run everything. Sometimes it just makes sense to stop at the first failure. And of course, for automation, Jenkins and Docker are probably one of the best candidates for helping you with that one. Sorry to be a little bit late. This is the wrap-up of my session. The name of the session was maybe, I don't know, it sounds like Shakespeare, famous note from Shakespeare Hamlet, or maybe look more like the Schrödinger cat experiment. If you don't test that, you don't really know if your unit code is behaving as it should be. So the cat may be even either dead or alive, or both. But if you try to start testing, then you are going to see, and hopefully it's going to be alive. It's easier to start with unit testing. Don't try to put the whole thing in a place from the beginning and set up your development environment and development process to include unit testing and has regression testing and has all that acceptance testing in the place if you have nothing. You cannot just do that overnight. Start with smaller pieces, and the smaller part is actually start by using unit testing. It's going to help you a lot. It helps also with code reviews. Your developer is going to be much more friendlier one to each other. If they discover bugs in somebody else's code, it increases the self-esteem. So it's something that you should do. And always try to come up with some regression test before doing a rollout. So before any release, try to run a regression test. Maybe you had a lot of features that you added, but if you also add regressions to that, it's not going to look good. Sometimes it's just override the feature that you added, and you spend a lot of time on doing that. A bug, it can just stop the application altogether and looks very good, very bad. I think that's it. So you should start testing. I don't think I said that, but it's really boring. So testing is not.